Hello, guys, and welcome back to MedZone African Motives. We are still continuing with our practice questions on forces and Newton's laws. Forces and Newton's laws. So, like I said, I'll be bringing you questions, one from the multiple choice side and one from the structured questions, so that we are able to get exposure and also get to understand how we answer these questions all round. So, without wasting time, let's dive deep to this other question that I've brought you today. So this is also from a past exam question paper. I just tried to find at least a question that will give us practice. So this is a question from a past exam question paper. It was a multiple choice question, and it was saying the frictional force acting on a sliding object by the surface in contact with it dash. It depends on air resistance, depends on the normal force, depends on the area of contact, does not depend on the type of surface. So they are saying that, let's say we have got a sliding object. I'll try to draw a slanting slope there. Let's just get to say we have got a slanting slope and we have got a sliding object. The object is sliding through, or else we just also have what? An object in that horizontal plane, and maybe this object is also sliding past through this horizontal surface. And now they're now asking the frictional force acting on these objects, the frictional force that will act on this object, the frictional force that will act on that object. It will depend on what? The frictional force acting on those two objects, it will depend on what? So we know that the frictional force actually is given by the coefficient of the friction uh, times the what? The normal force. Or else I can say coefficient of friction times the normal force. Either way, you can represent it in that way, you can represent it in that way. So what it simply means is the coefficient of the frictional force is dependent on the what? On the type of surface. It is dependent on the type of surface, while least this is the normal force of the what? The normal force acting on the object. It is actually acting perpendicular to the object. It is applied by the plane of the surface. So we can see that the frictional force depends on the what? On the type of surface. It depends on this type of surface, depends on the type of surface, and also depends on the what? On the normal force. So these are the two factors in which our frictional force depends upon. So the options that are given are saying depends on the air resistance. This is not true. Depends on the normal surface. Yes, this is true. Depends on the area of contact. No, this is not true. Does not depend on the type of surface. This is also not true. It does depend on the type of surface. So our answer there, or else our correct option was going to be B. So when you are answering multiple choice questions, this is exactly how you're supposed to be doing it. You are supposed to reason with the what? With the scenario that is given, and try to remember the concepts or else the laws that governs that scenario that is given. And then you can reason through with the options that are given. You try to find the most accurate option. You don't do a guesswork, or else you don't just get to take any answer. You take the most accurate one. So now we are done with our multiple choice question. Let's go to our structured question. So on our structured question, I also took a question from the same question paper, uh, which was question number 4. This is only for practice sake. So I just tried by all means to try and find as much questions from question papers that I can actually get to take that will best fit our cases of what? Of practice, because I want us to have exposure in all aspects in regard to forces and Newton's laws. So this was actually saying a body of mass 16 kg and radius of 0.10 meters is placed a distance x meters. So this is the 16 kg body that is having a radius of what? 0.1 meters, and it is placed x meters from another body that is having a mass of 48 kgs and a radius of 0.15 meters as shown on the sketch. Now they are saying state Newton's law of universal gravitation in words. Universal gravitation in words. So you should remember that we have got Newton's first law that states that an object will remain in its state of rest unless there is a what? Unless there is a net resultant force acting upon it. That is Newton's first law. Newton's second law, it is the one that tells us that if an object is acted upon by a net force, that object will start to accelerate in the same direction as the net force applied. And the acceleration will depend on the net force applied. And also we have got Newton's third law, which tells us that actions and reactions, they are equal and opposite. Now they want us to know about the Newton's universal gravitational law. What does the Newton's law of universal gravitation states in words? We know that in terms of formulation, this law is written in this way. It is written in this way. Now, in words, it simply states that every object in universe, each object in universe exerts a force of attraction towards the other object. That force of attraction that it exerts towards other object, it's directly proportional to the product of the two masses of the objects, but inversely proportional to the square of the distance that is in between these two, which is the distance between the two centers of the two objects. That is what we refer to as R. So when you want to state this law in words, I would simply state that each object or body in the universe exerts a force of attraction towards the other, so towards any other object or else any other body that is within that same universe, where now we are saying that the force, we are saying each object in the universe exerts a force of attraction towards the other, where this force, where the force is directly proportional to the product of the two masses of the object, and inversely proportional to the square of the distance between them. So when we say the distance between them, we mean the distance from the center of this object to the center of that object. That is what we refer to as R. So we are saying each object in the universe exerts a force of attraction to any other object that is within the same universe, where the force is directly proportional to the product of the two masses of the objects, and inversely proportional to the square of the distance between them. So whenever we've got two objects like this, it simply means that this object exerts a force of attraction, which is the gravitational force, a force of attraction to this object, as well as this object also exerting the same force of attraction. So these two forces are equal. And these two forces are directly proportional to the product of the two masses, which is the mass of this object and the mass of that object. But they are inversely proportional to the distance between the two centers, the square of the distance between these two centers. So that is simply what the Newton's law of universal gravitational law states. The Newton's law of universal gravitation states. Now, let's actually get to see what the next question says. It is observed that the 16 kg block exerts a force of magnitude 2.30 times 10 to the power negative 8 Newton on the 48 kg block when they are placed as shown in the sketch above. So we are saying this object is exerting a force of attraction on this object, where that force of attraction is equivalent to what? 2.30 times 10 to the power negative 8 Newton. Now they are saying, write down the magnitude of the force that 48 kg body exerts on the 16 kg body. Now we want the force that this object is exerting on this due to the attraction, or else due to the gravitational attraction. So we know that from the law of universal gravitation, the force that is exerted by the 48 kg block, which is A, and the force that is exerted by B, which is these ones, these two forces, they are equal according to the what? Newton's universal gravitational law. Therefore, we know that this force would actually be equal to what? It will actually be equal to 2.30 times 10 to the power minus 8 Newton. What is the reason? The reason is that each body will exert the same force of gravitational acceleration, which is equivalent to the product of the two masses and inversely proportional to the square of the what? Of the distance between the two bodies. You can give a reason to say that this is due to the Newton's what? Gravitational law, which says that this is equivalent to what? G m1 m2 over r squared. This will always be the same because m1 is this, m2 is this. They are the same masses and the distance between the two is the same. So you can say this is due to Newton's law of universal gravitation, which states that, and then you can state that law. So the answer was this, and the reason was this law. Simple like that. Now let's hear the last one. They're saying calculate the distance x. Now we are now supposed to calculate the distance x. How do we calculate that distance x? So in simple essence, we are saying the law that governs is saying Fg, which is the universal gravitational law, is saying the force of gravitational acceleration that is exerted by this object towards this, as well as the one that is exerted by this object towards that, is given by G m1 m2 over r squared. Now we have been given that to be 2.30 times 10 to the power minus 8 newtons. That is the magnitude of that gravitational force. Now what we now need to find, or what we now need to determine, is G, which is the what? Gravitational constant. G, the gravitational constant. And we know that the gravitational constant that we use is 6.6 times 10 to the power minus what? 11. 6.67 times 10 to the power negative 11. This will always be given in your data sheet. We use 6.67 times 10 to the power negative 11. So that is what you have to use here, 6.67 times 10 to the power negative 11. After that, you now need to insert the mass of this, the mass of that. And then you can find this distance by making R the subject. So by that, let's use this space. We are told that M1 is equal to 16 kg, M2 is equal to 48 kg, and then the force of attraction or the gravitational force there is equal to what? 2.30 times 10 to the power minus 8 newtons. And we know that G from our data sheets is equals to 6.67 times 10 to the power negative 11. So by using Fg being equal to G M1 times M2 all over R squared, we can simply come here and say Fg is what? 2.30 times 10 to the power negative 8 is equal to 6.67 times 10 to the power negative 11 times 16 times 48, all divided by what? By R squared. So we now need to make R squared the subject. We can actually take R squared that side and also get to take this one that side. We are interchanging. So here I would come and say my R squared will be equal to 6.67 times 10 to the power negative 11. And then I would come to say 16 times 48 all divided by this one, which is 2.30 times 10 to the power negative 8. And let's now use our calculators so that we can actually get to determine what becomes our answer there. So I'm now just going to punch in 6.67 times 10 to the power negative 11 to the power negative 11, and then with that I will multiply it by 16 and multiply it by 48, and then I get my answer, which I will now further divide by what? By 2.30 times 10 to the power negative what? Negative 8, which I'll now get to divide by what? By 2.30 times 10 to the power negative 8. Given that I'm getting an answer of 2.2272. I'm getting an answer of, so R squared would simply be equal to 2.2272. Now, how do I find R? I just apply the square root that side, square root that side. So by applying the square root that side, what becomes my answer? So all I need to do here is to say square root of 2.2272. So the square root of that was going to give me what? The square root of that was going to give me 1.492 meters. That is R. But is that what we are looking for? No, we are looking for X. We are looking for X. So this is R. R is equals to 1.492 meters. Now, let's go back to the question. Let's go back to the question and the drawing. We are looking for X, which is the distance from here to there. So you can see that we are looking for this distance. But Tina, we've managed to find this distance. We have managed to find that distance. We have managed to find that distance, which is R. So all we now need to do is to say R minus the distance from here to there minus the distance from there to there. Where this one, it's now the radius of that, and that is 0.10. The radius of that 0.15. So we are going to say R. So we are going to say X is equal to R minus 0.10 minus 0.15. That is simply what you are going to do there. So now let's go down there. This is question number 4.32. And now we are now going to say x is equal to r minus 0.10 minus 0.15. And what is our r? 1.492 minus 0.10 minus 0.15. What becomes our answer there? What becomes our answer? If we say minus 0.10 minus 0.15, we are going to get an answer of 1.242. That is 1.242 meters. X is the distance, so it's measured in meters. So this was going to be our final answer. So this is how you apply your universal gravitational law in solving these answers. So thank you so much, guys, for being together on this question. Let's meet in our next video, where I will also bring another question from the multiple choice side, as well as find another question from the structured question, so that we get as much exposure as we can. Thank you.